good day, Algebra. Welcome back to another year, another binder. Starting with CO1, really kind of a review of CO1 from pre-algebra, where we talked about whole numbers, integers, rationals, and irrationals. To start, we're just going to focus on what makes a number rational versus what makes a number irrational. So, memory time. What is, Blake, quiet please. What is a rational number? What is a rational number? An actual number. They are actual numbers. That is correct.
Ones that doesn't have any decimals?
So actually, a rational number does have a decimal, but something must be true about the decimal. Two things actually, one or the other.
Can't be repeating.
It is repeating if it's rational, or it can. Blake, quiet please. Or it can end, right? So a rational number is a decimal. I'll start with fraction. It's any fraction or a decimal that ends or repeats. Okay? It is a fraction or a decimal that ends or repeats. No, my handwriting did not get any neater over the summer. Sorry about that. A fraction or decimal that ends or repeats. And what is the symbol for a decimal that repeats? How can you look at a decimal and know whether or not it's repeating?
A line above the last.
Exactly, yeah. So if our decimal is 1.23 and we've got a line over the 23, it means it's 1.2323232323, et cetera, et cetera. If the decimal is 4.56 and the line is only over the 6, it means it's 4.566666. Right? Whatever is under the bar, that is the part that repeats. Okay? And so those would both be rational. An irrational number, we've already defined, Cade. Actually, no, the opposite. A rational number is a decimal that ends. An irrational number, decimal that does not end, does not repeat. That does not end or repeat. Okay? And there are really kind of three ways that we can signify a number is irrational. Sometimes if it's a very commonly used value, we assign it a letter or a symbol. What is a very famous irrational number that I know you've used before because you've worked with circles in last year's math packets? Pi, right? Pi is probably the most famous. It goes on forever. And rather than writing it out every single time, we assign it the Greek letter pi. We can also use 3 dots. If our decimal is 8.71492063 there's no repetition there, right? It goes on forever. We can notate that with a dot, 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 right? That dot, dot, dot means there's more to the story. When your parents send you a text on a Friday night and say, hey, you at so-and-so's house? And you respond with, no, dot, 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 right? There's something more there, okay? Same thing here. Or even, yes, dot, 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 okay? Or, Cade, you can also notate an irrational number by writing it as the root of a non-perfect square. You know, there's a difference between perfect squares and non-perfect squares. If you have the square root of 25, because that ends up being a whole number, the answer is 5, that would be rational. However, something like the root of 13, where there's nothing times itself that's going to get you to 13, that decimal is going to go on forever. So rather than writing it and putting the dot, dot, dot after it, we just leave it as root 13 and understand that it's an irrational number. So any fraction, rational, period, okay? A decimal that ends or repeats, also rational, but a decimal that does not end, does not repeat, an irrational number in kind of 3 different ways that we can show it, okay? So, Mr. Heavy Pencil, this means it's your homework. Basically, I want you to tell me whether each number is rational or irrational, and tell me why. Is negative 19.7 rational or irrational? Rational. Why is it rational? Because the decimal ends, right? I wouldn't write IR for that one because it's rational, but the next one I wouldn't write IR either because that one's also rational. Why? Cade? Shh. Root 36 is what? Why? Well, what does root of 36 equal? 6, right? The value equals 6 is an actual answer to it, so that would be rational as well, okay, because it is a perfect square. Yeah?
I have a question for the very last one.
Yes.
So it repeats, but there's always the one more one.
So there's a difference between repeating and there being a pattern, right? Patterns aren't always repetition. We see this pattern here of 1 2 1 1 2 1 1 1 2. Definitely some sort of pattern there, but does it repeat? No. Okay, doesn't repeat. You also see the 3 dots here. That's another hint that it goes on forever, and so this would be an irrational number. So there, Liam, is where I would use the IR, because that one is an irrational number. There's a definition between a pattern and repetitions. Not all patterns are repeating patterns. Johnny. 16:30 seconds. What do you think? Jack? Why? Because it's a fraction. Okay? Rational because it is a fraction. Okay? Then kind of the wordy questions down below here. It says, write the value of 9 3 ways as a negative integer, a fraction not in simplest form, using an exponent, and using a square root. Okay, so you get to pick 3 of those 4 ways to write the value of 9. And this might be a term that you might not remember from last year, but what is an integer? What is an integer? Yeah. A positive or negative non-decimal or non-fraction. A whole number is different. A whole number are only positive non-decimals, non-fractions. Integers can be positive or negative. Okay, Dayton, go spit out your gum, please. If you show it to me, then I know you have it. Yes. So, like using a square root, what would you write for it to be the value of 9? The root of 81 would be a value of 9. Okay. In our number system, are there more rational numbers or irrational numbers? Explain. And then for review, describe whole numbers and integers. We already talked about each of them briefly, but what are whole numbers and integers? For that one, you might need to look at another resource. Okay? That's it for today. I started the kind of the most easy way into it as I could. Short assignment, more or less review. Tomorrow, if we can play the number game, I think that would make everyone happy. What are the conditions to play the number game? Sophie, what are the conditions to play the number game? Everyone gets their homework done. Do I grade on right and wrong? No, all I ask is that you attempt it. So nothing blank. I can tell if it's random stuff, usually, so no. But I need to see that you at least attempted it. Your reasoning might be incorrect, but as long as you explain, right, and it's a rational thought, then that is all I ask for. Okay? Other questions on the assignment before you even get 9 minutes of class time to work on it? 9. The spirit of Christmas. Jack.
So kindergarten teachers don't even believe in homework. So I think you should really think about believing them.
Treat you like a kindergartner?
Yeah.
Okay, you know they hold their kids' hands when they walk places, right?
All right. Yeah, but at least I wouldn't have homework.
Okay. Abby. Okay. All right. Do you remember the outro? Yes, you do, Sophie? All right, I want to hear you the loudest. That's how you math.
Don't forget to like and subscribe.
All right.